All right, so I started this stuff way back in 1995. 1993, I started the initial background work on PHP. And I did it because the web in 1993 was really cumbersome. This is what it looked like to write web pages in 1993. This is a CGI script written in C. And this is really how we wrote web pages back then. This was before CGI PM, the Perl module that people started using. This was really, really early days, and it was a pain. Anytime you had to change even the slightest bit of HTML, you'd have to recompile your script, and all kinds of things would go wrong. And never mind trying to hand this off to an HTML designer. They didn't exist back then, but even if you wanted to, no chance. So most people started using Perl. To me, this wasn't a huge step up. You're still programming HTML in another language, which I have never been a fan of. I want my HTML to look like HTML. I didn't want to encode my HTML inside Perl. Plus, this was still a CGI program, which means you had to fork and exec the web server on every single request. You had to fork the process and then execute Perl. And on 1993 hardware, starting up a Perl processor is really, really expensive. It's still expensive today to do that. Nobody does it. No high volume site of any sort would even consider using CGI to serve stuff. And back then it was even worse because the hardware was slower. So I wanted something that looked more like this. I wanted my HTML to look like HTML with just a couple of tags here and there where you needed something dynamic. Both because I needed to teach people how to create web pages because nobody knew how to do that in 1993, 94. And I didn't want to teach them how to program at the same time. It was plenty hard enough just to teach them sort of the concept of HTML to begin with. And then once they started asking me, well, how do we make it dynamic? I didn't want to then say, okay, well, this is HTML, but to then make it dynamic, you have to learn this. That was just too big of a step for people to get. But if I could treat the dynamic parts just like any other HTML tag, it was much, much easier to get them to a point where they could start making pages. So this is basically what I wrote for PHP version 1, was the ability to sprinkle a few dynamic tags in there. Now my goal with this was actually to provide kind of a framework for writing really complicated applications. So the front-end folks that did the HTML design would be playing in this, but the way I saw it, there would be a back-end engineer, much like myself, that would be writing all the heavy lifting and then providing tags using my tag framework, basically my templating system, to expose the back-end logic of the web application to the front-end developers. And that was sort of the concept of PHP back then. And it worked really nicely for the tags that I had implemented. And basically I provided a whole bunch of example tags. This is how you would build a guest book, for example. This is how you would build a database-backed application that would keep track of website hits. And this is how you build an authentication system. And people would take these example apps and they would just use them verbatim. And then they would ask me, well, how about something that keeps track of products? We need an example of that. I say, well, you're supposed to write that. This is your business, right? No, we don't know how, but how would we do this? So I would write another example on, well, it's easy. It's do like this. And I kept adding more and more tags to the language. I kept adding more things. And nobody ever wrote the C backend stuff. They were always asking me to do it. And I sort of became the back-end developer for hundreds and hundreds of websites back then, which was a little bit of a drag. Because I was doing consulting, I was doing my own work, but on the side, I was the back-end guy for lots and lots of other people that didn't know how to program. And it kind of went from there. At some point, I figured out that this idea of mine really sucked. This whole concept that people would actually write C backends to my templating system just wasn't the case. The web was growing way too quickly, and there were not enough developers out there that took it seriously. Especially back then, the web was a toy, it was a fad, it wasn't going to go anywhere. No serious computer science person would spend any time on it. It just wasn't interesting. And that was a problem for all these companies looking to figure out, well, how do we take our stuff and put it online? In the beginning, they just took their product documentation. So, okay, well, let's put our product docs online so people can look up how to use our things. And to do that, they went to their tech writers and said, well, you guys wrote the documentation, just put it online. And the tech writers said, okay, Word, save as HTML, stick it on the web server. Okay, that's not so hard. Then the next step the company would say is, well, now we also have our product database with prices and availability. Put that online, please. And now the tech writers have become the web team because they were the last people who put stuff online, right? So now they go to the web team and say, hey, connect this website to the database. And these tech writers, they're in Word, like save as database back website. No, that doesn't work, right? And they were kind of lost at that point. But this is really kind of where PHP built itself and built sort of the huge following, is that lots and lots of people had very little time to get their stuff online, to build dynamic websites, and they needed a really quick and easy way to do it. And PHP was the first solution that could do that. It wasn't the first language by any means, but it was the first end-to-end ecosystem that had kind of ticked off all the pieces. So we talk about the LAMP stack, right? Linux, Apache, MySQL, and PHP. It wasn't an accident that these four things came together. There were a few of us out there that sat down and thought about, how do we hook these things up? How do we get from the operating system to the server itself, to the database, out the socket, to the end user's browser? We had to have these components to do all this. And how do we do that efficiently without going through too many abstraction layers? And that's where the LAMP stack came from. In the early days, robustness and performance were the main things we were looking at. Security-wise, there wasn't a whole lot of security things we needed to worry about. There was no cross-site scripting, no XSRF. There was none of the fancy things that you can do today were available back then because JavaScript barely existed, and it certainly couldn't do any of the fancy things it can do today. There was a little bit of security on the database side. SQL injection existed back then, of course, so you had to escape your queries and things. Other than that, security wasn't that big of a deal. We were growing too fast to worry about security. But performance and robustness was the main thing we kept looking at. My first version of PHP was actually a patch to the NCSA web server. So I had baked PHP into the web server itself because that was the only way to avoid having to fork an exec and avoid this huge performance hit that something like CGI-PM took. So I needed the web server and the scripting language to be a single entity. It needed to be in the same process to be fast. People didn't necessarily like installing my version of this NCSA web server. And this is when Apache was born. Apache was born from a bunch of patches, that's why it's called Apache, a bunch of patches to the NCSA web server, and mine was one of the main patches to this. So I helped start looking at Apache, and there's a very smart guy that sat down and said, look, we need an actual API. We need some kind of module API for Apache so that we can extend it without having to keep patching it. People can basically publish their own modules for it. And PHP was one of the first big modules for Apache that did interesting things. And this was all performance oriented, all this work. And also, on the robustness side, we had lots of arguments about how to handle that, event-driven, threaded, process-based. And it was always very much, well, I was always pushing hard for a process-based approach, because if you have a multi-threaded server that has 2,000 threads going and you crash, you take down 2,000 requests. If you have a process-based one where every process just has one request at any one time, it crashes, you take down one request. And code is never perfect. It never will be perfect. It's not perfect today. PHP segfaults occasionally on even the biggest sites out there. But it only takes down one request. And often the segfault is actually at the end of the request, so the page has been served up, but in cleanup, it ends up segfaulting once every 200 million requests maybe. So you serve the request, the user got its content, you have a segfault, you don't even notice unless you sort of go through the logs with a very fine-tooth comb. And that's nice. For a while at Yahoo, we were segfaulting millions of times a day. And it didn't affect anything. So sometimes robustness is more about sort of how you architect things, and you can't necessarily wait for the perfect solution to things. And you need to worry about the ecosystem, architect the ecosystem correctly to handle this stuff. So the other thing I thought about back then was, how are people getting online? Where are they putting their pages? And most people put things on shared hosting ISPs. So an ISP would start up and they would put thousands and thousands of users on the same machine. And they needed a technology that they could install on these shared servers where people could safely run websites next to each other on the same Apache instance. And I added things like maximum memory, maximum CPU timeouts, CPU timeouts. So if someone does a while true loop that just sits and spins the CPU, it's going to get killed off after a little while. And it's not going to completely destroy everybody else on that server. And ISPs like that, and they flock to PHP for that reason. Most of the other technologies that were out at the time didn't take that into account. Even when mod Perl came out a few years later, it was way too powerful. It gave users control right down to the request phase level of Apache, which meant that as soon as you install mod Perl and give a user access to it, that user could completely change everything about that Apache server, which means that nobody else can use that same Apache instance, which is a problem, because back then there was just no way without running multiple Apache instances on multiple IPs. You couldn't have multiple Apache instances next to each other on the same machine. And we didn't have VMs or anything like that, so it just wasn't cost effective to give everyone their own Apache instance. So mod Perl never took off for that very simple reason. It was too powerful. And then on the scale side as well, I made a very early decision not to create an application server. I didn't want to maintain state in any way whatsoever. And since I don't have to maintain state, PHP doesn't have any scaling issues at all. If your PHP application doesn't scale, it's your fault. It's something you added. It's something you wrote. It's how you architected it. It doesn't scale. PHP itself scales horizontally infinitely, which you can see by the fact that Yahoo and Facebook and Wikipedia and all these huge, huge sites are PHP driven, right? They just add servers when they need more concurrency. So this approach, or this idea of the perfect sandbox, where every single request is discrete. We bring up everything we need for the request at the beginning, and at the end of it, we shut everything back down. We free everything. There is nothing that maintains state on the server side in PHP. Now we have session support, and there is a default file handler where you can save sessions on the server, but it was designed so that you would provide your plugin. You would say, okay, these are my session set save handler functions. This is how I'm going to save my session, either in Oracle, MySQL, Postgres, whatever on the back end. And then scalability becomes a problem of the storage layer. And this is where you need to figure out how do you scale your storage layer. And these applications, these databases are much more set up to handle that situation. This is what they're designed to do. So the scaling up part came from that architecture decision, and also worrying about performance all the time and worrying about things scaling up. As technical people, as geeks, scaling up is actually pretty easy in the sense that it's a natural thing for us to think about and worry about. How do I avoid extra locks? How do I avoid any scaling issues? How do I avoid various things, various bottlenecks? How do I identify bottlenecks? How do we solve it so we can scale up a lot? What we don't think about as much is how do we scale down? And engineers are terrible at scaling down. How do we scale down this thing so the weekend warrior who doesn't know anything about anything can still take their idea and put it online. And very, very few environments, ecosystems, languages, whatever out there built by geeks address that. And if they try to, they do it badly, really badly. So things that you need to address the scaling down issue, you need decent documentation, you need lots and lots of examples, and all the examples have to focus on the problem that this person that you're trying to reach is trying to solve, which is why PHP has always been a web-oriented language. Every example you see in the PHP documentation is web-related. It's all about solving the web problem. Every other language out there was always general purpose. This is the language. It's kind of your own job to figure out how do we use this tool to solve the web problem. With PHP and the whole ecosystem, it gave that. So, okay, this is how you use this tool to solve the problem. So scaling down came from that. And also just thinking about how do we make things simple. So stuff like register globals, which lots and lots of people hate, was a direct result of this scaling down. And PHP wouldn't be where it is today without register globals. Because in the early days, teaching people how to do this stuff, it was very, very nice to say, look, here's a web form. These are the web input fields, the form input fields, name, age, birthday, whatever. And here you have $name, $age, $birthday, right in your tag language. You can just echo them back out. Now with cross-site scripting and things that came 10 years later, that was a terrible idea. But those didn't exist back then. It wasn't such a huge problem to echo user input directly back out. And as long as you initialize your variables, it's also not really a variable injection issue. There wasn't really a technical problem with that, and it gave a lot of benefit on the scaling down side of the house. So scaling up infinitely, scaling all the way down as far as you can in the same code base is not easy. And you end up making some enemies along the way because people at the high end really hate some of the things that have been done to scale all the way down to the low end. And vice versa sometimes. I mean, folks at the low end look at some of this stuff and go, whoa, this is way too complicated. Why is it so complicated? Why can't we dumb this down to the point where I can understand it, right? And striking that balance where you can sort of reach both ends is really, really tough. So there are some few things in there I always get asked about. So case-insensitive function names. This was because HTML in 1995, people hadn't quite decided if it should be uppercase or lowercase tags. And it was a very religious battle for a long time, whether all HTML tags should be uppercase. And PHP kind of slid in and just looked like HTML tags. And I wanted those tags to be available to both religions, the uppercase folks and the lowercase folks. I didn't want to pick a side. So PHP tags initially were all case insensitive, and they were all functions initially, so function names were case insensitive. As we moved along, HTML tags ended up all being lowercase. The one religion one killed off the other side. And I should have at some point just made that switch. But there's one of these things where, well, I have thousands of servers out there running this code. If I turn off and switch, I'm going to break half of them. And why? I mean, if you have two functions where the names only differ in case, what the hell are you doing? Right? So there was never really a good point where I should have done. Now looking back, now that there are, I think, 250 million sites running PHP, I should have done it when there were 3,000. Naming inconsistencies. There really aren't any naming inconsistencies in PHP. There's just a lack of sort of consistency across all of PHP, but within each piece, it's always named after the underlying library or API that we're using. We haven't abstracted most things. PHP tends to be a very thin layer on top of the underlying functionality that it gives you access to. So stuff like string functions that come right out of libc, we use the underlying libc argument ordering. For people always asking about array and string functions, where array stuff is needle haystack, and string stuff is haystack needle. But it's always that way. All array things are needle haystack. And all string things are haystack needle, simply because of the underlying APIs that we that we wrap. Dollar signs, people say, well, why do we have to have dollar signs on variables? When I wrote my first parser, it was just easier, especially for string interpolation. When you're putting a variable inside a quoted string, you have to have some kind of indicator that this is a variable. You could either put curlies around both ends, or you can put a dollar sign at the beginning. Well, it's one less character, let's put a dollar sign at the beginning. And then it just made it consistent across the language. And it also made it easier, so you could have variables that have the same names as functions and things. Without the dollar sign, you wouldn't be able to do that. Globals, I could spend hours just talking about global variables and how I think PHP is the only language that actually gets it right. Where you have to specifically say, this method or this function is going to step on this global variable. I really like that. It's very nice that you can see that, hey, I know exactly, hey, I'm touching this variable. It's not declared global in here. I know that it can have no side effects anywhere else in the code. I spent months tracking down a problem similar to that, the big Northern Telecom call distribution piece of code that was millions of lines long, written in C. It was a nightmare. I really think other languages should copy that, but they're not. Register globals we talked about, magic quotes, yeah, that was me being lazy. Back when PHP only supported 1 or 2 databases, and those 2 databases both quoted the same way, I just tossed magic quotes in, going, well, instead of me having to quote every SQL query, let's just do it automatically. As PHP started to support more databases, that obviously became a bad idea, and it had to be done right. So we talked about performance, the mod PHP that I wrote, the Apache module, robustness. The limit clause came out of my robustness work as well, where sometimes you send off an SQL query to the server without realizing that you're getting back a million rows. Especially in the early days, MySQL, mini-SQL that I was using didn't have cursors or anything like that. So if you send off a query asking for a million rows, well, you didn't ask, you say select star from something, not realizing you're getting a million rows, you're sitting there waiting 12 seconds for all this data to come across the pipe. And you're only going to show the first 10 results anyway. You're going to paginate this thing. There's no point reading a million rows when you're only going to show 10. So the limit clause was kind of an obvious thing. Anybody else in my position would have done it. It wasn't brilliant or anything. It was just, I was there, I needed it, and stuck it in. And other databases seem to like it. They tend to copy it from then on. We talked about the others. So, now, 2013, the current stable version that's out is PHP 5.4. How many people here are already on 5.4? Wow, not. So the reason to switch to 5.4, lots of performance improvements. There's a whole list here of things that we've made better, performance-wise. There's a built-in web server, which I really like for debugging things because I can start up just PHP as a server, and I can have multiple requests without having the overhead of a web server or the complexity of a web server when I'm just debugging PHP. I think IDEs might use it. Please don't use it as a production web server. It wasn't built for that. There are lots of production web servers out there that you can use. We also have traits. I like to explain it as compiler-assisted copy and paste. They're essentially mix-ins. But it's easy to think about it. You define a trait, and then inside a class you say use that trait name, and it's just as if you have taken that block of code in the trait and pasted it into the class. It's flattened, so every function is flattened, and everything is flattened. It appears to the rest of the code as if those functions or those properties were part of that class all the time. There's also the short array syntax. So instead of writing array bracket bracket, you can just use square brackets now, similar to JavaScript. And function array dereferencing. Right? So if a function returns an array, you can dereference it right on the function call. Just like any other method inside a class, closures now have access to $this without any tricks or anything like that. Which also means that it has access to private properties, obviously. You can write whatever you want in here and access a private property here. If you don't want your closure to have access to $this and private properties, you can mark it static. You can return static function and then trying to use all of this inside will give an error. The short echo tag is available now all the time without short tags being turned on. There's a new session object, so instead of defining those 6 session save handler functions, you can just provide an object that implements the session object interface that has the 6 methods inside. There's a callable ticket. The use of closures has grown quite a bit in PHP, so now if you're passing a closure to something, you can say that this function takes a closure or a callable. Much better support for Asian characters and special chars and entities. Better multi-byte support throughout. Some JSON improvements. So you can implement the JSON serializable interface. And if someone tries to JSON encode your class, it'll call your JSON serialized method. Some of interest to this group is probably that we're now using MySQLnd by default everywhere. You can override that at compile time, and I'm sure distributions are doing that in certain places. But by default, if you just say, I want to compile PHP with MySQL, MySQLi, PDO, those are all going to use MySQLnd now. And we'll talk about a little bit why we chose to do that. There's iterator support added to the MySQLi result stuff. Binary notation, just like you do 0x, you can now do 0e for binary. And a few other minor improvements here and there. Request time float. Well, I'm here for those who can't see. We already have server request time, which is basically just the timestamp that the request came in. But sometimes 1 second granularity is just not enough, especially for busy servers. You need it down to the microsecond. So we also now have a request time float, which is the microtime granularity request time. So a little bit on performance. Here I have 4 servers. The yellow and green are PHP 5.3 with APC. APC is an opcode cache. The blue and red is PHP 5.4 using opcache, which is a different opcode cache. Opcache is the new one that's going to be bundled in PHP 5.5, but it is available for 5.4 and 5.3 through Perl. You can install it. It's about 10 to 15% faster than APC as an opcode cache. And PHP 5.4 is another 10 to 15, 20% faster than PHP 5.3 on average. Depends on what you're doing. So combining the two actually can give you quite a bit of a boost. So this is real world traffic. This is actually Etsy traffic, averaged across all the different types of Etsy requests. This first graph is the average user CPU per request. So both sets of servers get exactly the same, but we get about a 20% improvement in terms of the amount of CPU it takes to serve up that load. User CPU. System CPU, the difference between the two is the user CPU is your application running, things that are simulating CPU, whereas system CPU is time spent in system calls. You talking to the disk, you talking to the network card, you talking to whatever, right? So at the system CPU level, there's also an improvement. You're spending less time in system calls in 5.4. Memory usage is also lower. We were averaging about, well, it says down here, the average 24.3 megs per request per Apache process, which dropped to 19 megs per process, which means that your server density can be a little higher. You can put more concurrent requests per server. You can fire up more Apache clients basically on the box. And finally, what's really important is the response time or the latency. Right? So we were averaging 481 or 590, sorry, and after upgrading 5.3 to 5.4, that dropped by about 110 milliseconds. So without fixing your code, you can get yourself a 20% boost in your latency simply by getting off of 5.3 onto 5.4. So in trying to do that, there's a few things that might trip you up. If you're not already on UTF-8 everywhere, it's probably time to start getting off of ISO 8859-1. The world has moved on. The world is UTF-8. So the default for the HTML special charge and entities is now UTF-8. So if you're passing in stuff that's not valid UTF-8, you're going to get an empty string back, unless you specify. You can go in, you can specify your char set at the end there. But if you have thousands of lines of code but you haven't specified, it just assumes 8859-1, you're kind of screwed. You have to go through and you have to fix your code, and you have to tell it that, yes, I'm actually still on 8859-1. You shouldn't be. The real fix, the long-term fix, would be to get on the UTF-8. There's a new notice. You probably all run across the times when you get a string array printed on your web page because you try to echo out something that's an array as opposed to iterating through it. Now there's a notice when we end up doing that conversion from an array to the string array. Register globals is now completely gone. We disabled it by default, I don't know, 8 years ago or something, but now you could still always turn it back on explicitly back then, but now you can't. As of 5.4, if your app still relies on register globals, it's time to fix it. Magic quotes, same fate. We also removed variable break continues, so if you had break with a variable, continue with a variable, which is really odd code, that doesn't work anymore. To avoid hash collision attacks, we also have set max input bars to 1,000. So that means if you have more than 1,000 get fields on a request, or if you have more than 1,000 input fields on a post request, it's going to truncate them at 1,000. Most times you wouldn't have 1,000 fields on a single page. It'd take a long time for someone to fill that out. But there are actually cases. We thought 1,000 was way more than anybody would need. But sure enough, we got plenty of bug reports saying, hey, you broke our web app. Because we have more than 1,000 cookies, or we have more than 1,000 post fields, or some API thing has more than 1,000 post requests on an API response. PayPal broke, for example. Well, people using the IPN, the instant payment notification from PayPal, where you provide a post URL, say, hey, please, when someone pays, send us a post request with all the information about that payment. PayPal sends more than 1,000 fields in that post request sometimes, depending. If it's a big order with lots of stuff, it can be more than 1,000 fields, which is nuts. But obviously, it's just an INI thing. You can configure it. You can even do it per page. You can say, just for this particular page, we're going to allow 100,000, whatever. The reason to limit it was because hash algorithms can be rather finicky. We have a really fast hash algorithm in PHP that doesn't protect itself from deliberate hash collisions. So if you read the algorithm, you can figure out, okay, here I'm going to make a key, or I'm going to make a little string that's going to hash to the same bucket as this string, and this string, and this thing, and this string. So when a hash algorithm works perfectly, you throw random data at it, you get a very nice even distribution. Say you have 1,000 buckets, you'll get one item per bucket if you throw 1,000 random items at it. Not quite, there'll be one with two buckets full and some empty buckets, but on average, you'll get one item per hash bucket. But if you deliberately try to defeat the hash algorithm, you can throw keys at it such that they all hash to the same bucket. And when you get multiple elements in the bucket, we create a linked list. So first item, and then a link to the next item, link to the next item, which is fine if you have less than 100 or so per bucket, or even less than 1,000 per bucket. It's not bad. Computers can go through 1,000 links pretty damn fast. It's not so fine if you have 1 million, 2 million, 10 million. Every time you add another one, you have to go through 1 million links to get to the 1,000,001. And then the next one comes, we have to go through 1,000,001 links to get to 1,000,002. And it just gets slower and slower and slower and slower. And you end up eating lots of CPU. So people are crafting these very, very strange looking post requests and posting them to PHP servers. And basically doing a DOS attack and eating up lots and lots of CPU. With this default setting, that's impossible, because 1,000, even if they all hash to the same bucket, 1,000 takes no time at all. So that effectively kills the DOS attack, but it does limit you slightly in the number of post fields you can handle. Some other things that could break, there are a few new words, keywords. Callable instead of and trait are now keywords. So if you have functions named that, you'll have to rename them. Usually not a problem. Bit about signatures and abstract constructors. It's a little too detailed. And a few other things. You could go through the list yourself. We've removed a couple of things. There's a MySQL list DBs that's been removed. You can do a show select instead. Yeah, a higher requirement for PDO. You need at least MySQL client with 4.1. Again, shouldn't be a problem in any sort of modeling system. A couple other minor things. So, MySQLnd, I promised you to talk a bit about that. It's the new native driver. It's not that new, it's been around for years. But it has some very interesting characteristics. It's specifically written for PHP, which means that it uses the PHP streams layer, it uses the PHP memory manager, and it also means, because it uses the PHP memory manager, there's a lot less copying memory around. The old MySQL client library would allocate memory for, so if you do a select to a server, the server would find the result and send it across the wire, and it would get allocated in the client library. Then in PHP, when you wanted to iterate through it, you would fetch a row at a time, and you would basically copy it from the MySQL client library into PHP memory as you're iterating through it. Now the MySQL client library and PHP are the same process. So you're simply copying things from one place in the process to another place in the process because these two pieces of code don't know about each other. And that's how most things work. When you use some kind of third-party library, it has its own way of managing memory because it's a generic library. It's written for anybody to use, so it has to have its own way of doing things. Now when we have better integration between the library and PHP, we can avoid this copying of things. We can just have a single copy and always use it. And because we use the streams layer, there's some improvements there, and better L1, L2 cache usage because of it. So there's performance reasons to go that route. But there's also some very unique features, some very unique reasons to go that route. We can do asynchronous queries, which are quite interesting. Right? So synchronous queries, you send the query, you sit there, you wait for the result, you can't do anything else in this database connection until you get the result back, you send another. So if you have 3 queries to do, it'll take the sum of the time of the 3 queries, it'll take you that long to get through the 3 queries. And that's how pretty much every PHP application works today. But with asynchronous queries, you can launch 3 queries simultaneously. You say bang, 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 you kick them all off, and then you wait for the results later on. And as they come in, they can run concurrently. You reap the results at that point. And I'll show you an example in a bit. There's also better persistent connections. Now, before MySQL with libMySQL client didn't actually even have persistent connections because of some security problems related to that. That's been solved in MySQLnd, so now you have your persistent connections back in MySQLi. There's some neat performance statistics calls, so you can actually get through the client library. You can ask the client library directly all kinds of questions about performance. You get this big array back of all kinds of metrics about your communication with the database. There's a MySQL fetch all call that can basically give you access to all the rows. Since they're already in memory, unless you're doing an unbuffered query, they're already there in memory. You can just grab them and go. And there's a cool plugin API that can be used to extend MySQLnd and hook into all kinds of places. And I'll show you a few of those that exist today. So async queries, they look something like this. Right? So normally, if you're going to send off 3 queries to 3 different databases, or to the same database, it doesn't have to be 3 different databases, it could also be the same. But in this case, I'm kind of emulating going through 3 shards, for example. I need to execute this query on all the shards because I don't know which shard this thing is at, or I'm doing some kind of sum. It's like on all my shards, how many users are over 21? can't see the side of my query there, but select ID from users where age is greater than 21. Obviously, I'm going to have to hit all my shards because this is not something that you can shard on a single one. So here I go through, I connect to my 3 databases, hosts 1, 2, and 3, and then I go off and I send off queries on all 3 DB connections here. For each of these DB connections, give me an array of all the user IDs that are over 21. Oops. Now, with async queries, it's a little bit more complicated, but not that much. We do the same thing. We create 3 connections to our 3 different database servers. We loop through all 3 connections and send off the query just like before. The only difference is at the end. So we have a DB query with our SQL. We send it off as an async query, which means that this call is going to come back right away. And it's not going to block. So it's fast. Then we go through our DB connections, and we basically call poll. So we have an array, all DBs here. This is from our list of DB connections. So we feed it that array both as read, error, and reject. It's going to fill in. I didn't do any error checking here, so they're all going to be successful reads, I'm assuming. So it's going to come back. MySQL poll is going to come back. It's going to wait 1 second. You can also make it more granular. There's a microsecond argument on this as well, but it's going to wait maximum of 1 second. Hopefully everything's going to come back long before. But it's going to come back as soon as the first query is ready. It has a result for you. It's going to come back, and you then figure out which one was ready. You read the result. So the MySQL I read async query basically says, go get me the result from this asynchronous query. And then you fetch it just like before. You can go through and basically you unset it. Say, okay, I'm now done with this particular one. I've read the results from this particular connection. You unset it from your list. And your do while here is going to continue until you've reaped the results from all 3 queries that you sent off. Now, this looks more complicated, which usually means it's slower. But in this case, because these things are asynchronous, these 3 are going to come back, basically almost at the same time. Assuming your shards are running about at the same speed, these 3 are going to come back, bang, 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 and it's going to run about 1/3 of the time as the other example. So the other thing MySQLnd gives you, query stats. So here we go through, we just connect to a host, and we send off a query, we fetch all, and we say MySQL I get client stats. And you can also get it per connection. In this case, I only send off 1 query on this connection, so the client and connection stats are going to be the same. But here's a list of all the things you can get back. Right? The number of bytes sent across to the server, which was pretty short because it was just a short query. The number of bytes received, which is longer because it was a set of users. So the result set is almost always bigger than the query. Number of TCP packets, number of packets received, right? Protocol overhead. And it gets really, really detailed. If you go look at the MySQLnd documentation on php.net, you'll see an explanation of every single one of these fields if you want to dig in. And you can see it's very, very, very detailed. Which for a normal application you don't necessarily need, but for any sort of monitoring of what's happening on your database, it's really nice that you can poke it. You can poke specific connections, you can poke specific clients as well, and give you that. You can graph it, stick it into Nagios or something, game your script. And it goes on. There's tons. Way too detailed, actually. So plugins. These are really, really cool. This lets you do things you wouldn't normally be able to do in a MySQL client at all. So the main ones so far are these 5, 4, I guess. MySQLnd MS. MS stands for Masterslave. It was originally just a read-write thing, where it would automatically figure out to send reads to the slaves and to send writes to the master without you having to do it at the application level. right? So you can just send off queries, connect to the database like normal, and do your selects and do your updates, and the Masterslave plugin would figure out where these things should go without you having to do that at the application level. But it has grown beyond that. There's a query cache, a user handler, and a memcache one as well. We'll talk about those in detail. So the Masterslave one, but it has also grown to support lazy connections, which is kind of cool. So you can open up connections to your main master database, all your shards. You can open up all these connections, but if you have MySQLnd DMS in there, they're going to be lazy. They're not actually going to open the connection until it's needed, which is kind of nice. The read-write splitting. It also has load balancing. So normally you have lots of slaves. So if you go to read from a slave, you have to figure out which slave am I going to read from. Here it does that, and you can round robin. It can do a random, then sticky, or just a random, or you can provide your own algorithm for figuring out. You could do some kind of load check, health check that gives you ping times or something. You can feed that in, and that'll use that to figure out which slave to go and request things from. You can also, via query hints, in MySQL you can have SQL query hints. You can say, you can basically guide sharding and petitioning type queries to the correct host. And MySQLms, just by putting a little hint, a little comment in your SQL query, you can tell it to go to the right shard, and it'll handle that for you. And there's tons more, actually. This thing is becoming a bit of a beast of a plugin. If you go to php.net/MySQLnd for Masterslave, you can see all the stuff about this particular plugin. Next one is the query caching plugin. Lots of ORMs will cache queries locally. Often, and pretty much always, you do the select query. It takes a little bit of time, especially if it's a join. It'd be very nice to cache that locally for the next hit. And I see a lot of people just caching everything in memcache, regardless of anything. And you tend to have your memcache read rate be pretty dismal. And it's hard to figure out. And even so, there's a lot of code to also stick in there to try to intercept all these things and to stick stuff in the memcache automatically. And this is what the QC plugin can do. You can take your standard PHP MySQL application, install this query cache, and configure it to do the memcache caching on its own. And either you can say, please cache all selects in memcache, or in one of these others, ABC user cache memcache SQLite. There's also an in-process. And if you do that, if you tell to cache everything, it's probably not going to be that effective. But you can also do it via hints. SQL query that says cache this one, right? You should have some sense of where things should be cached. So you can simply install this plugin and put a couple of hints in your queries, and problem solved. then end up hitting your memcache through an SQL statement, and it'll translate that correctly and get everything back nicely. So it's a way of converting existing stuff that really probably shouldn't have been in SQL to begin with, sticking them in the InnoDB memcache without doing any application changes at all. And that's what most of these plugins do. They let you do some very fancy things that would take a lot of heavy lifting on the application side, and basically it lets you leave the application code exactly as is without changing anything, and just kind of munging the MySQL client layer a little bit and having it do different things before it talks to the MySQL server. So in that sense, it's a neat thing for large legacy applications. It's a way of getting results quickly without having to rewrite all this legacy PHP code. All right, finally, some new stuff coming in PHP 5.5. We have our first release candidates out for this thing, or first beta, I guess. And main things, a couple of performance things. Nested calls are a bit faster. We're pre-allocating call stack now, which gives us a little bit of a boost as well. But the big thing is we're bundling an opcode cache, like I talked about, the op cache. We also have generators coming. So a generator is basically a way to keep state inside a function and then yielding that state at a specified time. So here, if I'm generating this X range, I can say I want to, from the start of the range to the end of the range, instead of returning an array with, say, 1,000 elements, we can return one element at a time. Kind of like looping through a database result. But here, we can yield one element at a time with the yield keyword. So every time you call it, it's going to yield the next value of the range. Right? So you can for each through this thing, and you're going to get back one at a time without ever having the entire array in memory. Now, for just 6 elements, that's not a big deal, but for 1,000,000 elements, that might really make a difference. There's a finally keyword now, so you can do cleanup on your try catch. So finally will always get called. So if your try goes through, there are no exceptions, that's fine. If there is an exception, it'll still end up calling finally on an exception. Basically, it's for cleanup. Like if there's something in this block of code that you need to know that will always get cleaned up no matter what, you stick it in the finally clause. You can use listed for each now, or in 5.5, meaning you can do the first level of dereferencing for multi-dimensional arrays, right in the for each. Not a huge thing, but can make things a little easier. And you can now do constant array and string dereferencing. So if you feed it an array, or in the new 5.4 syntax, you can say, an array, I want element 2 right away. Or you can have a string, you can get the 4th element out of that string, or 4th character out of that string, right? Not quite sure why you would do that, but it seemed like a missing thing. There was no reason not to let you do that. But honestly, I can't think of a really good reason why you need to. And then a couple of other minor little things. The curl upload stuff was very obtuse, the way it was implemented with the ampersand to specify the file name of the file you want to upload via curl. And now it's been completely rewritten in the same way. And we also have a simplified password hashing API coming out in 5.5. It's just a high-level set of functions that basically abstract all the existing things. We found that a lot of people didn't know how to hash a password correctly. And you see all these sites out there with security problems because people broke in and they stored their passwords unencrypted, or they stored it with a really bad encryption, right? We've seen base 64 stored passwords. And so they just go, whoa. And that's part of this scaling down issue. We've kind of lost track over the last couple of years. We've sort of gotten ahead of ourselves, thinking everyone, of course, knows this stuff. Everyone knows not to base 64 encode passwords. But how do they know? If nobody told them not to. So the idea here is that let's not make them think about it. Let's give them a password hashing API that says make a password and hash it. Well, here's the password, hash it nicely with a good, secure algorithm. And let's not let them choose. Now, we're not taking away the low-level functions. Of course, you can write your own, but I'm hoping to see lots of applications just switching over to the password hashing API. Because then we also have a single place where people, where the security folks can audit this one. And this is always going to be more secure than anything a normal person can come up with, hopefully. All right, so I hope I've convinced you to upgrade to 5.4, if not to 5.5. It'd be nice if you could help us test 5.5, contribute back any bug reports, feedback, whatever on it. We always get a rash of bug reports and complaints once we release something. But we go through 6 months of release candidates, alphas and betas, asking people, please test, let us know, did we break something? Like I said, there are 250 million sites out there running PHP, which means there's, I don't know how many trillions of lines of code out there in PHP. We can't possibly not break stuff, right? Any change, any tiny little change we make is going to break something out there. But it'd be nice to know about it, especially if we start seeing a trend. Say, okay, well, we made this change, we've now broken, we got lots of people complaining. Usually, we get 0 complaints. It's not until we first release it, or even like a year after release, when people start upgrading, they start complaining. It's a little late in the game at that point. So please, 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 if you rely on PHP in any way whatsoever, please take an afternoon and test some of the new versions of PHP and give us a hand. All right, the migration guides are online. For the 2 guys in the back, we're still here. It shouldn't be. There's a PHP 5.2 to 5.3 migration guide. Same with 5.3 to 5.4, 5.4 to 5.5 is already written. It's there. You can read it now. Everything you want to know about MySQLnd is at php.net/MySQLnd. You don't hide things very well on the PHP site. Usually you can go to php.net/ whatever you're interested in. We'll take you to the right page.